In this video, we're going to look at density. So as with everything, we should be really pushing the definition, and a good definition. So density is the amount of stuff in a given space. Now, I just said a good definition. This is not the most formal definition, and I wouldn't encourage students to write this on the exam, but it's a good way of introducing it. It's a good general way of introducing it that does make sense to them, and then you can link it to the particle model that you've looked at, and you can say, something like this is very dense. There's a lot of stuff in a space, but if we look at a gas, there is not a lot of stuff in a space. Then we can introduce the formal definition, which is the mass per unit volume. Now, at GCSE, you can probably get away without including unit, but when we at A level, we usually put this in because it just means one mass per one volume. So formally, density is mass divided by volume. We use the Greek symbol rho. Now, it's infuriating that maths use D is mass over volume, and this is really irritating because in physics this is not acceptable, and we have to really make it clear that maths here use a different symbol. We are going to use rho. One way of trying to encourage students to remember it is you can tell them they really love density, mass over volume, but as with most things, if you can really push the definition in words, this is better for them in the long term. Density is also one of the very few exceptions where we're looking at multiple units. So usually we will be working in SI base units. So we will be looking at kilograms and meters cubed. But actually, because we're often working with small amounts of stuff, we can also use grams per centimeter cubed. And students need to be happy with both of these units. And we need to be able to give them questions where they might be given kilograms and centimeters cubed, and they need to make a conversion of one of them. Other important basic facts: less dense objects float on more dense objects. So you can have some really nice discussions now about the Dead Sea, for example, about salt water versus regular water. You can make some nice density columns where you can make salt solutions of different densities, and you can layer them really nicely and get these really pretty test tubes full of liquid based purely on density. It's really easy to do as long as you add them really slowly to the tube. They do need to know that water has a density of 1 gram per centimeter cubed. This is a very useful fact, and then obviously if things are more dense than this, they will sink, and if they're less dense than this, they will float. So there's two parts to the unit of density. There are doing the mathematical questions where they are expected to recall this formula and apply it, and also the practicals. We're going to look at a couple of interesting questions or ways of answering questions, and then I'll run through the practicals. So obviously, if students are given a question that says find the density, the mass is this, the volume is this, is really easy. They just need to know that density is mass per unit volume. But often they'll be given questions maybe like this, where it says a metal has a density of 40 grams per centimeter cubed. How much mass is in some volume, 18 centimeters cubed? Now, one way, of course, is to teach students how to rearrange. We can teach them that density times by volume equals mass. And we should be trying to do this, but students do often find this hard. So maybe we can approach this in a way that doesn't actually require any maths. If we can get students to be really clear what density is and what it means, if we can get them to realize that 40 grams per centimeter cubed means that for every 40 grams there is a volume of 1 centimeter cubed, we can get the answer without any maths at all. So this relies on this definition up here, and it relies the fact that per means divide, or it means 1 over the thing that's per, so 1 over volume. So it's really, really worth pushing this definition of per that means divide, or we could say it means for every, and then we could say it means divide. Right? Your time is well spent pushing this. So here we've got for every 40 grams, there is a volume of 1 centimetre cubed. So if we have 1 centimetre cubed, then we have 40 grams. If we had 2 centimetres cubed, we're going to have 80 grams. You can probably see where this is going. If we have 3 centimetres cubed, we've got 120 grams, etc., etc. So if we actually scale this up, and scaling up is quite a good language to use because even weaker students are pretty happy with this idea of scaling up. Then at 18 centimetres cubed, when we scale this up, we're going to end up with 720 centimetres cubed. So we can use exactly the same approach if students are asked to find the volume. So salt water has a density of 1.2 grams per centimetre cubed. How much volume will 24 grams take up? So again, we get them to start by saying, what does this density actually mean? It means for every 1.2 grams, there is a volume of 1 centimetre cubed. Now, we haven't got 1.2 grams. 1.2 grams would correspond to 1 centimetre cubed. How much would 2.4 grams be? Well, even the weakest students can do this kind of scaling. So now if we had 3.6 grams, we would have 3 centimetres cubed. And again, we're going to keep on scaling this up until we get to 24 grams, where we find that we have 20 centimetres cubed. So it requires no rearrangement of formula, the most basic of maths, and this one definition here, all right, where we're really focusing on the units. The other good thing about focusing on the units is we can tell students that they can cheat in the exam, okay? We can tell them that if they look at the answer line, it will always have an answer line, and then it will say kilograms per metre cubed, or it will say grams per centimetre cubed. And we can tell them, well, hang on a second, we're actually being given the formula here. We've been told it's mass per volume. So you don't actually have to remember the formula. So the last thing that students have to be able to do is carry out a practical to measure density. So this is really divided into 3 parts. This is divided into finding the density of liquids, regular objects, and irregular objects. So liquids is really easy. You get yourself a mass balance and you get yourself a measuring cylinder, and you fill it with your liquid. Now, our volume is read straight off the measuring cylinder. And of course, our mass is our mass from the mass balance minus the mass of the empty container. All right, and this is the one tricky step that students might get tricked with. And then, of course, we use density is mass over volume. For regular objects, typically we'll be looking at things like cubes, where the volume is length times width times height. Higher tier could be given, something like a cylinder, where we need the cross-sectional area times the length, so pi r squared times length, and other shapes could be given, but probably this is the most likely one. And then, of course, density is mass over volume using a mass balance. Right, we always use a mass balance. We never use scales. Scales are not accepted on the mark scheme. We use a mass balance. And then the irregular object is the slightly longer one. This tends to be a 6-mark question. So this involves you getting a container, you fill it right to the top with water, Then you put in your object, and the water will of course spill out because it's overflowing. So you collect the water in a measuring cylinder, and then this gives you the volume. The mass is of course from a mass balance, and then we use density as mass over volume. So this is sometimes known as a Eureka can, after Archimedes, and it's always worth telling the story about Archimedes and the fact he got in his bath, overflowed, shouted Eureka, ran through the streets naked. They usually remember this. And this forms the basis of the required practical. So here is a kind of 6-mark method. This should get you 6 marks on most exam questions. And it's really crucial that you practice this a couple of times for students, because they always miss up a couple of steps. And for some reason, particularly when you're doing the required practical, this step here seems to catch out lower ability students.